Welcome. Today we're diving into a fascinating topic, how learning actually happens inside the brain. We'll explore the information processing theory, a key idea in cognitive psychology that helps us understand the step-by-step journey of information as it moves through our minds. Unlike older theories that focus only on stages of development, this theory explains the actual process of learning. By the end of this video, you'll have a clearer picture of how information travels from your senses through your memory and finally becomes knowledge you can use. Let's get started by comparing the brain to something we all use every day, a computer. Information processing theory often compares the brain to a computer system. Think about how a computer works. You input information, the computer processes it, stores it, and later retrieves it when needed. Our brains operate in a similar way, though they are much more complex. When children learn in school, information passes through several stages, just like files moving through a computer. Understanding these stages helps us see where learning can break down and how we can help students succeed. Let's walk through each of these stages together. It's like a computer, the brain processes information in a series of steps. These include sensory input, attention, working memory, long-term storage, and retrieval. If any stage doesn't work properly, learning becomes difficult. Educational therapists pay close attention to these steps to identify where a student might be struggling. By understanding each stage, we can better support learners and help them overcome challenges. Now let's take a closer look at the first stage, sensory input. Learning begins when information enters the brain through our senses. These senses include sight, hearing, touch, smell, and taste. In the classroom, the most important senses for learning are usually sight and hearing. For example, students might read words on a page, look at diagrams, or watch the teacher write on the board. They might also listen to explanations or hear classmates discuss ideas. At this stage, the brain is simply receiving raw information. But just receiving information doesn't mean learning has happened yet. The information must move to the next stage. Let's imagine a real classroom example. A teacher writes the sentence, "The lion lives in the savannah," on the board. One child sees the sentence, this is visual input. Another child hears the teacher read it aloud, this is auditory input. Both children have received the information through their senses. However, just receiving information isn't enough. The brain still needs to process it further before true learning takes place. This brings us to the next crucial stage, attention. Attention acts as the gateway to learning. Even though our brains receive thousands of sensory signals every moment, we can't process them all. Attention works like a gatekeeper, deciding which information gets through to our thinking system. If a child pays attention to the teacher, the information moves forward. If the child is distracted, the information stops here. This is why attention is so important in the classroom. Let's look at how attention works in real life. Picture a classroom where the teacher is explaining fractions. One student is watching and listening carefully, while another is staring out the window at a bird. Both students hear the teacher's voice, but only the first student is truly paying attention. The second student, distracted by the bird, doesn't process the lesson. Later, the student might say, "I didn't understand the lesson," but the real issue is that their brain never processed the information in the first place. Attention is the key to moving information forward in the learning process. Children with attention difficulties often miss important instructions, forget lesson explanations, or seem careless. But the real problem is that the information never entered their thinking system. Educational therapists use strategies to improve attention, such as reducing distractions, using visual aids, giving short instructions, and engaging students with questions. By strengthening attention, we help students move information to the next stage of learning. Once attention selects the information, it moves into working memory. Working memory is like the brain's temporary workspace where information is actively processed. However, working memory has a limited capacity. Most children can only hold 3 to 5 pieces of information at a time. If too much information is presented at once, some of it may be forgotten. Let's see how this works in a classroom setting. Imagine a teacher says, "Take out your math book, open to page 25, and solve the first 3 questions." The student must remember 3 steps. Take out the book, open to page 25, and solve 3 questions. A student with strong working memory can hold all 3 steps and complete the task. But a student with weak working memory may forget 1 or more steps, leading to incomplete work. The teacher might think the student wasn't listening, but the real issue is limited working memory. Working memory is also crucial for reading comprehension. For example, to understand the sentence, "The boy who was wearing a red hat ran quickly across the playground," a reader must remember several details. "There's a boy, he's wearing a red hat, he's running, and the location is the playground." If working memory is weak, the child may forget earlier parts of the sentence before finishing it, making comprehension difficult. This shows how important working memory is for understanding and learning. Information in working memory is processed successfully, it can be transferred to long-term memory. Long-term memory is the brain's permanent storage system, holding knowledge for long periods, sometimes for life. Examples include vocabulary words, multiplication tables, grammar rules, historical facts, and scientific concepts. Once information enters long-term memory, it becomes much easier to use and recall. Let's see how this works in practice. Students first learn multiplication. They may need to calculate each problem step by step. For example, to solve 6 times 7, a beginner might add 6 7 times. This takes effort and time. But after practice, the student memorizes that 6 times 7 equals 42. Now the answer comes instantly because it's stored in long-term memory. This is why practice and repetition are so important. They help move information from working memory to long-term storage. Practice helps information move from working memory to long-term memory, a process called memory consolidation. Educational therapists use repetition, spaced practice, and meaningful connections to strengthen long-term memory. By practicing skills over time and making connections to what students already know, learning becomes more durable and easier to retrieve later. Retrieval means accessing information from long-term memory when it's needed. Learning is only useful if the brain can retrieve stored information. For example, a student may have memorized multiplication tables, but during a test they must recall the answers quickly. If retrieval is slow or inaccurate, the student may struggle even if the information is stored somewhere in memory. Let's look at a real-life example of retrieval. Imagine a student preparing for a spelling test. They memorize the word beautiful. During the test, the student must retrieve the correct spelling from long-term memory. If retrieval works well, the student writes beautiful correctly. If retrieval fails, they might write beautiful or beautiful. The knowledge exists somewhere in memory, but the brain couldn't access it accurately at the right moment. This shows why retrieval is a critical part of learning. Information processing system works like a chain. Each stage, sensory input, attention, working memory, long-term storage, and retrieval is a link in that chain. If one link breaks, the whole learning process can fail. Understanding this chain helps educators and therapists identify where a student might be struggling and how to help them. Let's look at what happens when attention fails. If a child doesn't pay attention to the teacher, the information never enters working memory. For example, if the teacher explains how to solve a math problem but the student is daydreaming, the student won't be able to solve the problem later. The real issue isn't understanding, it's that the brain never processed the explanation in the first place. Sometimes the child hears the instruction but can't hold it long enough to act. For example, if the teacher says, "Take your science book, open page 14 and answer question 2, but the child only remembers the first step, the task remains incomplete. This isn't a listening problem, it's a working memory issue. Recognizing this helps teachers and therapists provide better support. Sometimes, a child understands the lesson but forgets it later. For example, they might learn new vocabulary today but forget the words next week. This means the information didn't transfer successfully into long-term memory. Identifying this issue allows educational therapists to use strategies like repetition and spaced practice to help the child remember better. Sometimes the information is stored in memory but can't be accessed quickly. For example, a student knows multiplication tables at home but can't recall the answers during an exam. This is a retrieval problem. Educational therapists can help by practicing retrieval skills and using memory drills to make access to information faster and more reliable. Educational therapists analyze each stage of the learning process to find out where a child is struggling. They ask questions like, is the problem caused by weak attention, limited working memory, poor long-term storage, or difficulty retrieving information? By pinpointing the weak stage, therapists can design targeted interventions to help the student succeed. If working memory is weak, therapists may teach strategies like chunking information using visual reminders and giving step-by-step instructions. Chunking breaks information into smaller, manageable parts. Visual reminders help students remember steps, and clear instructions make tasks easier to follow. These strategies support students in holding and processing information more effectively. Retrieval is weak, therapists may use memory drills, retrieval practice, and quizzes. Memory drills help students practice recalling information quickly. Retrieval practice involves regularly bringing information to mind, which strengthens memory connections. Quizzes provide opportunities to test recall in a low-pressure setting, making retrieval easier during real exams. Most important idea to remember is that learning is not a single event. It's a process that moves through several stages: sensory input, attention, working memory, long-term memory, and retrieval. If any stage fails, learning becomes difficult. Educational therapy focuses on strengthening each stage so that the brain can process, store, and retrieve information effectively. Let's revisit sensory input with a visual example. Imagine a student reading a textbook and looking at diagrams. The eyes send this information to the brain, which receives it as raw data. At this point, the brain hasn't processed or understood the material yet. The next step is to focus attention on what's important in the material. Now, consider auditory input. A student listens to the teacher explain a new concept or hears classmates discussing ideas. The ears send these sounds to the brain, which receives them as raw information. Again, learning hasn't happened yet. The brain must pay attention to process and understand what was heard. One way to improve attention is by reducing distractions in the classroom. This might mean seating students away from windows or noisy areas or providing quiet workspaces. By minimizing distractions, students can focus better on the lesson and move information forward in the learning process. Visual aids such as charts, diagrams, and pictures can help capture students' attention. These tools make lessons more engaging and help students focus on key information. Educational therapists often use visual aids to support students who struggle with attention, making it easier for them to process and remember new material. Giving short, clear instructions is another way to support attention. When teachers break tasks into smaller steps, students are less likely to feel overwhelmed and more likely to remember what to do. This approach is especially helpful for students with attention difficulties, ensuring they can follow along and complete tasks successfully. Asking students questions during lessons helps keep their attention focused. When students are invited to participate, they are more likely to stay engaged and process the information being taught. Educational therapists encourage teachers to use questions as a tool to maintain attention and promote active learning. Chunking is a strategy that helps students manage information in working memory. By grouping related pieces of information together, students can remember more with less effort. For example, instead of remembering 7 separate numbers, a student can group them into 2 or 3 chunks. This makes it easier to hold and process information in the brain's temporary workspace. Visual reminders like sticky notes or checklists can help students remember steps in a task. These tools provide a visual cue that supports working memory, making it easier for students to complete multi-step assignments. Educational therapists often recommend visual reminders for students who struggle to hold information in mind. Giving instructions one step at a time helps students with limited working memory. Instead of giving a long list of directions, teachers can break tasks into smaller, manageable steps. This approach reduces the load on working memory and increases the chances of completing tasks successfully. Repetition is a powerful tool for moving information into long-term memory. By practicing skills and reviewing material regularly, students strengthen their memory connections. Educational therapists encourage repetition as a way to make learning last and ensure knowledge is available when needed. Spaced practice means reviewing information over time rather than cramming all at once. This technique helps the brain consolidate memories and makes it easier to recall information later. Educational therapists recommend spaced practice to help students remember material for the long term. Making meaningful connections between new information and what students already know helps strengthen long-term memory. For example, linking a new vocabulary word to a familiar concept makes it easier to remember. Educational therapists encourage students to find connections and relate new material to their own experiences. Memory drills are exercises that help students practice recalling information quickly and accurately. These drills might include flashcards, timed quizzes, or oral recall activities. By practicing retrieval, students make it easier to access information during tests and real-life situations. Retrieval practice involves regularly bringing information to mind, even without looking at notes. This strengthens memory and makes it easier to recall information later. Educational therapists use retrieval practice as a key strategy to help students prepare for exams and remember what they've learned. Quizzes are a practical way to test retrieval skills. By answering questions without looking at notes, students practice bringing information out of long-term memory. Regular quizzes help make retrieval faster and more accurate, which is especially helpful during exams. Educational therapists use a systematic approach to identify which stage of information processing is causing difficulty. By observing students and asking targeted questions, they can design personalized interventions. This approach ensures that each student gets the support they need to succeed at every stage of learning. Let's quickly review the 5 key stages of information processing: sensory input, attention, working memory, long-term storage, and retrieval. Each stage is essential for successful learning. If any stage breaks down, learning becomes difficult. Educational therapy focuses on identifying and strengthening weak stages to help students achieve their full potential. Learning is a journey that involves many steps. From the moment information enters through our senses to the point where we can recall it during a test, each stage plays a vital role. By understanding and supporting each part of this journey, educators and therapists can help every student become a more effective learner. Educational therapy is all about strengthening the brain's ability to process, store, and retrieve information. By focusing on each stage of the information processing system, therapists help students overcome challenges and unlock their learning potential. With the right support, every student can become a confident and successful learner. Summary: information processing theory gives us a powerful framework for understanding how learning happens in the brain. By breaking learning into stages: sensory input, attention, working memory, long-term memory, and retrieval, we can identify where students struggle and provide the right support. Educational therapists play a crucial role in helping students at every step, ensuring that learning is effective, lasting, and meaningful. Thank you for joining us on this journey into the science of learning.